Hi class, this is David. Let's take a look at this problem here. One quick note here about Megastat. This is not related to this problem, but I wanted to remind you, Megastat will not run on a Macintosh computer, and also for your final exam, you will not be able to use Megastat. So the best way to do this for those two reasons is StatCrunch. So let me show you how to do that. We have a police department released the number of calls on different days of the week for the month of October, as shown in the table to the right. Use alpha 0.01 to test the claim that different days of the week have the same frequency of police calls. So clearly we can see here that the number of calls is numerically different for each day of the week. But what we want to know is, statistically speaking, are these numbers the same or not? So the null is going to be that the police calls occur with the same frequencies on different days of the week. And the alternative is going to be that for at least one day it has a different frequency of calls. So at least one day has a different frequency of calls than the other days. Okay? So we know that these two choices here are out because these are null statements here. Okay? Actually, this one's not, but this one is. Okay? This one here says that they're all different. So this one's not true. Okay? This one here is not true because the word days is pluralized and it says at least two. Okay? And that's not the burden of proof. The burden of proof is that at least one day. It may be more than one. Okay? But my burden of proof only requires me to show that at least one of these days is statistically different from the other. So let's go ahead and determine this answer. Here's StatCrunch here. Now, on a previous problem, I actually reported the expected frequencies. Okay, you can see here that I have not. It is not required to report the expected frequencies. And let me show you that feature in StatCrunch for this problem. So go to Stat, Goodness and Fit, chi-square. I do have to give it the observed values. I will always have to do this. Okay, but under expected, I have the option here of either selecting the expected frequencies if they're the same, or I can click on this and say that they're all going to be the same. And by clicking on this button, StatCrunch will add all these values and divide by 7 and determine the expected outcome based on these observations. So let's hit compute, and you can see it did it right here. So the observed are here, the expected values are calculated here, and as you can see they're all 209.28571, and of course in the real world this number is ridiculous. I cannot have a fraction of a call, of a police call, but numerically these are valid, and I need to keep all these decimal places to make the problem work out correctly. Here's the chi-square value, 28.532. And I don't know if you noticed or not, but the p-value is extremely small, so 0.0000. So since the p-value is very, very small compared to alpha 0.01, I will reject the null. There is sufficient evidence to warrant rejection of the claim that they are the same. What is the fundamental error with this analysis? Well, let's look at these. Let's see, because October has 31 days, okay, so it looks like the first part of the statement is true for all 4 responses. 2 of the days of the week occur more often than the other days of the week. Well, we'll have to think about that for a second. So if we do some math here real quick, 31 divided by 7 gives us 4.42, okay? So that means that a week is roughly 7 days goes into 31, a little bit about 4.5 times. So that means that it's going to be more than 2 days. They're going to occur more often. It's actually going to be more like maybe 3 or 4 days. One of the days of the week occur more often than the other days of the week. Well, that's not true. 3 of the days of the week occur more often. Well, that's probably more likely, because if we subtract this from 4 and then multiply this by 7, that gives us exactly 3 days. Okay? So, I mean, again, you'll have to look at a calendar in order to be able to make this determination. But very quickly, you can see here that for the month of October, 3 of the days are going to occur more often than the other 4 days for a typical week. And again, how did I make that calculation? I took 31 and divided it by 7, and that gives us basically 4 weeks and some change. So if I subtract off the 4 weeks, this is the change. So these are the extra days. And if I multiply that by 7, that tells me how many days extra there are in the month of October, and it's 3. So therefore, this is going to be the answer. And it makes sense, okay, because depending on what year we're in, okay, we know that 3 of these days are going to have 3 extra days worth of police calls, and that is going to influence the outcome. Thank you.